Namaskar to all of you. Today we have to do the second module of chapter 1, chemistry, chemical reactions and equations. In the first module you studied about various chemical changes, the differences between physical and chemical changes, the chemical equation, the various parts of chemical equation, and how to write the chemical equation. Today we are going to go one step ahead and we are going to study how to balance a chemical equation. Now, first of all, why do we need to balance a chemical equation? What is the need? See children, you have studied in class 9, law of conservation of mass. What does it state? It states that mass can neither be created nor it can be destroyed in a chemical reaction, which means a new substance is formed, but the mass of all the elements is same. So how do we do that? How do we balance a chemical equation? How do we get to know that it is balanced? By equating the reactants with the products. That means the left hand side of a chemical reaction should be equal to the right hand side of the chemical reaction. Okay. Let us take one example. I have taken a classic example which is given in NCERT also. Iron reacts with steam forming iron oxide and hydrogen. As you see, this is a word form of the chemical reaction, and when I write Fe plus H2O, Fe3O4 and H2, this is the symbolic form of the chemical equation. Now, the unbalanced equation or the raw equation, or which we may even say the basic equation, is also known as the skeletal equation. Now what do we have to do? We have to balance this skeletal equation. Now the first step of balancing. The first step of balancing, what do? We make boxes around all the reactants and products on both the sides. So this is the first step. Why have we made these boxes? The boxes denote that we cannot tamper, we cannot make any change with the chemical composition which is inside. Which means I cannot make H2O as H2O2 in order to balance my chemical equation. Alright? Now step number 2. This is step 1. Step 2. Step 2, what do? We make a small table in which on the extreme left side we mention all the elements that are there that are involved in a chemical equation. Right? In this particular equation we have Fe, we have O and we have H. Do we have any other element? No. Okay. On the first column we write the number of these elements which are there on the left hand side. Like Fe, only one is there, H, 2 are there, O, 1 is there, and similarly on the next column, the right hand side, we write the number of atoms of these elements. Like there are 3 atoms of hydrogen, 3 atoms of iron, 4 atoms of oxygen and 2 atoms of hydrogen. So we have done the step 2. The step 1 was making the boxes. Step 2 was making a table and tabulating the various elements. Now step 3. Step 3 is basically there is no fixed method by which we can balance. It is just a hit and trial method. Hit and trial method, which means we will just try to equate equate the left hand side with the right hand side by just putting simple whole numbers as coefficients, right, which we can put on the left, on the just ahead, this or this or this or this. Now let us try to equate it. Like, we'll start with iron. Iron is 1 over here and 3 over here. Now in order to make this 3, what should I do? I should multiply it with 3. Okay? I should multiply it with 3. Now, next, O is only 1 over here, and on the right hand side it is 4. What do I need to do? I should multiply it by 4. Alright? But when we multiply this by 4, how do I do it? I have to place 4 over here, isn't it? 4 over here. So, by multiplying H2O by 4, there is a change in the number of hydrogen atoms also. Like, now the left hand side hydrogen atoms become 8. Isn't it? Now, in order to equate these hydrogen atoms, what do I do to make this also 8? I multiply this by 4. So, I put a 4 over here. Alright. Now, all the elements on the left hand side are balanced, or they are same as that of right hand side. So, our equation is balanced. Now we need to add the physical state. This is step 4. Physical states of all the reactants and products. Like, iron is a solid. This is steam, so I will write G. Iron oxide is solid, and hydrogen is in gaseous form. Now once I write the states of matter, I remove these boxes. Now my equation is balanced. So again, to recap the steps, the first step, put the boxes around each reactant and product. Second step, make the table. Third step, hit and trial method to balance the elements. And the fourth step, to put the states of matter and remove the boxes. Alright, so we are going to practice a few examples. Now, example number 1, hydrogen plus oxygen forms water. H2 plus O2 forms H2O. Now, initially you will have to make these boxes and you will have to make the table for doing the balancing of reactions. But slowly, when it will come to your practice, you can directly do the balancing. So, I will first do the first step, put boxes around each. Now, how many hydrogens? This is LHS, this is RHS, this is my table, a small one. These are 2, this is 2, this is 2, this is 1. So what do I need to do? I just need to balance oxygen. How do I do that? By multiplying it by 2. So I put a 2 over here. If you see now, the number of hydrogens have changed. So now this has become 4. What do I need to do in order to make this one also 4? I need to multiply it by 2. Over here 2. Now my equation is balanced. 4, 4, 2, 2. Now what do? I have to do? I have to write this equation along with the states, physical state, and remove the boxes. Okay, let us quickly do this one also. The classic example of burning of magnesium ribbon, MgO2 forms MgO. Now if you see, Mg is just 1, oxygen is 2 over here, 1 over here, so I need to make this 2. When I make this 2, now this time I am not putting the boxes. What happens? Magnesium also becomes 2. Over here it was 1, so I put a coefficient 2 over here. Now if you see, magnesium is balanced, oxygen is balanced. So this will come with practice. Now again I am going to write this equation with my symbols of physical state. One more. Calcium oxide plus water forms calcium hydroxide. It also mentions heat. So heat we are going to denote as a symbol of delta in the products. If we see, calcium is 1 over here, 1 over here, oxygen is 1, 1, 2 over here, and over here 1 into 2, 2. Hydrogen is 2, and over here it is 2, which means my equation is already balanced. What I need to do, I just need to put the symbols. Calcium oxide is solid, water is liquid, and calcium hydroxide is again a liquid. Is it a liquid or it is an aqueous solution? Because I am dissolving in it in water. Okay. Now next, lead nitrate, it says solution. This is the symbol of lead, this is the formula of lead nitrate. Potassium iodide, simple. Lead iodide. And potassium nitrate solution is KNO3. Now this is a little this type of equation which involves many elements. We will again make table. We have lead, we have potassium, iodine, and we have nitrate ion. The polyatomic ion can be kept as it is. This is left hand side, this is up. Lead 1 over here, 1 over here. Potassium 1 over here, 1 over here. I 1 over here, 2 over here. Nitrate 2 over here and 1 over here. So we see that we need to start with balancing nitrate or iodine. If we multiply it by 2, so both of them become 2. Over here I write 2. Okay. When I write 2, we see the potassium also gets changed because it is KNO3. Now, because we have made it 2, this has become 2. And I need to make potassium also, I need to make it 2 over here, and I need to make iodine also 2. Over here, it is Ki. If I just put 2 over here, it will get K also becomes 2, I also becomes 2. So my equation becomes balanced. Now what do I have to do? I need to add symbols. So I'll remove the box. This is aqueous. This is aqueous. Lead iodide is a precipitate, and KNO3 is again an aqueous solution. So I hope you find this video fruitful in understanding the concept of balancing of equations, and I would request you to practice similar equations for your homework. Thank you.